Hello, I'd like to talk to you about constructions. So when you start a construction and you're looking at a blank page, it can be a little bit overwhelming. So one of the things I like to do is to make sure that I give myself a point to put my compass point down. If you just take a compass and make some circles, sometimes it's difficult to remember where you put that point down. Most likely, one of the things that we're going to need besides just a point is we're also going to need a line. So when starting a construction, I like to start with a line. It doesn't really matter what type of construction you're doing. Often we're going to need some sort of line. Now, this line might be too long, it might be too short. We can adjust it later, but it's nice to at least have a place to start with your compass. It makes the whole process a little less overwhelming. So one of the most important constructions that shows up everywhere is a perpendicular bisector. Perpendicular means the lines will intersect at 90 degrees. And bisector means that the line that's here will get cut into two congruent pieces, meaning it will get cut in half. So what I'm going to construct is a line that passes through this line at 90 degrees. It doesn't just hit it, it hits it at 90 degrees. It also cuts this line in half. So all we have to do is just build a circle with our point on one of the endpoints. And we have to build a circle with our point on the other endpoint. Now, there you go. And when you're using a compass, one of my favorite activities ways to do is to turn the paper. Just kind of relax your compass like you're holding a pencil, and you just turn the paper. I did not intend for my compass setting to be the same width as my starting line, and that doesn't have to happen. If you had maybe made it a little smaller, then your circles would be a little bit smaller. That would have been acceptable. If you had made it larger, I think we probably would have gone off my page. And so it doesn't really matter how big the compass is. What sometimes happens to people, though, is that their circles are too small. And what we're looking for is an intersection where two circles meet. And if you make them too small, they won't meet each other. So I didn't do one on the other side. I will. You can see these two circles are too small to meet. What we're looking for is a point that is the same distance away from our two endpoints that we started with. And the thing that a compass does is it creates a bunch of radii . Those are all radius of this circle, and they're all the same length. That's what a compass does. It creates lines that are all the same length. And how many does it create? It creates an infinite number of them. And if you keep your compass the same size when you draw the second circle, then you create a radius over here that is the same size as those radii. And you create another one down here. And you can create one more over here. And what you get is an isosceles triangle up here and an isosceles triangle down there. And if we connect these vertices on our isosceles triangles, we get a perpendicular bisector. And that happens because, obviously, this line is equal to itself. This angle is 90 degrees right here. And it has to be 90 degrees because we created 4 congruent triangles. And if a full circle is 360 degrees, then each angle has to be a quarter of that. They each have to be 90. So we've created 4 triangles that are equal to each other. And if these 4 triangles are equal to each other, then this side will be equal to this side. So this is a perpendicular bisector. When you're all done, it looks a little messy. It doesn't need to look this way. Here's another perpendicular bisector. Start with a line, any size line that you would like. Go ahead and make sure that your compass is wide enough so that when you make circles, actually intersect. And all I did was make a circle around this point and a circle around this point. They meet here and here. If I connect this point to this point, I get a perpendicular bisector. And why this is so important, such an important part of our constructions, is when I connect here to here to here to here, like I did with this peak shape, you get a rhombus. And if I'm really careful to make sure that my compass is set to the width of my line when I start, then I get from here to here to here, these lengths are all the same. I get an equilateral triangle. And if I have an equilateral triangle, then I have 60-degree angles. And if I turn my paper this way, this angle right here, this one here, that one right there, this angle, oops, sorry, this angle right here got cut in half by that perpendicular bisector. So a perpendicular bisector is a great tool for a lot of different uses. So one more time, here's how you do a perpendicular bisector. Start with a line, no matter how big. Make sure your compass is big enough to touch on both sides. Draw a circle around one endpoint, draw a circle around another. Oops, mine didn't meet. Find where they meet. That's the meeting points, perpendicular. The other skill that happens sometimes as an important skill is copying a line segment. So if you want to copy this length right here, you simply just open up your compass to this length like that. And then you can copy it wherever you want. Maybe you want to shorten this orange line so that it's the same length as right here. Just put your compass right here on the end, draw a little arc. And if we cut all this off from here to here, and highlight that, is the same length as here to here. Now maybe you want to just do it somewhere else. Start with a point. I like to start with a line. And I will just cut this line off where I don't need anymore. So from here to here is the same length as that one. And all I did was just make sure my compass was set to this length. So I can go around cutting lines wherever I want to, and they'll be the same length. Get rid of all this, and this section is now the same length. Now, if you just start with a point, and you draw a circle around that point, you have a lot of options for where you draw a line of the same length. You can go here to here, and that will be the same length. You can go here to here, and that will be the same length. You can go here to over here, and that will be the same length. Or you can go here to there, and that will be double the length. These two constructions, copying a line and a perpendicular bisector, are the basis for every construction that we do.